Okay, so really happy to see all of you. Really happy that we finally restart the year. And Johan will talk now about AWS Well-Architected. Really happy you're here. Thank you.
Welcome. Hello, everyone. I'm really taken back how many of you came here today. It's really great to see so many people interested in the topic. My name is Johan. I'm a solutions architect at AWS. And today we will talk about AWS Well-Architected. I will start with giving an overview of what the Well-Architected Framework is. 6 pillars that it consists of. And then we will do a deep dive into 3 of those pillars with examples, so it's a little bit more tangible for you. And then I will close out this talk by giving you some points how you can get started in adopting Well-Architected for your own teams, for your own organization. With Well-Architected, we want to put you into a position where when you look at the work teams are developing, you can answer the question, are you well-architected? Confident are you that these workloads are according to best practices in the cloud? And hopefully most of you will answer yes. After all, we have great people in our teams. Nevertheless, there is always room for improvement, and adopting Well-Architected allows you to move quicker. By reducing firefighting and automating things, you free up your time to features and deliver them more rapidly. The Well-Architected framework helps you to uncover risks, potential risks, and reduce them before they interrupt your teams and disrupt your business. It also brings decisions to the surface. In the great majority of cases, the problem is not that people make incorrect decisions. It's that they don't make decisions at all that they should be making. By being aware of the decisions that you should make and having relevant information that you need to make them puts you into a great position. And finally, Well-Architected allows out the best practices that we've seen and experienced of building workloads in the cloud by many years and reviewing thousands of workloads on AWS. We deliver this as a set of questions with the company those questions, as well as design principles across 6 pillars. And think of these questions as deeper dive follow-up questions to the one that we've heard before. Are you well-architected? Pillars are operational excellence, security, reliability, performance efficiency or cost optimization, and sustainability. Today, we will dive deeper into the operation, into reliability, and as well into sustainability. But before we do that, I want to quickly summarize what the pillars are about. Security is our top priority at AWS. And the security posture workload is essential in assessing if it's well-architected. The security pillar touches you can use cloud technology to protect data, systems, and assets in a way that improves the overall security posture for you. The performance efficiency pillar is about improving and optimizing the computing resources of your workloads and maintain that efficiency as the demand on your workload changes and as technologies evolve. Is a set of practices for building and operating cost-aware workloads that deliver business value while minimizing the cost incurred. So after this quick rundown, let's dive into first pillar, the operational excellence pillar. Operational excellence is the ability to run and monitor so it delivers business value and to continually improve supporting processes and procedures. And we have designed to guide you towards operational excellence. And a key theme or a key element that you will see not only here, but in other pillars as well throughout the well-architected framework is using automation. Specific for operational excellence, it's about automating operational procedures so you can run them automatically in response to events. This frees up your time, it reduces human error, and it gives you consistent results. You should also design your workloads so that they're able to prevent changes made to it. For example, new features that you release. So this allows you to introduce beneficial changes to your systems. And you should introduce these changes in small increments that allow you to roll changes if a failure occurs. Give your teams time to improve your operational procedures. As your workload evolves, so should your operations. And at the same time, try to go one step further. Try to anticipate potential sources of failure and remove them, or put before they, so you can effectively handle it should they materialize. And a great is to run game days with your team, where you go through scenarios, you review procedures. This allows you to validate that these procedures are still effective, and it allows your teams to practice them so that they're confident to execute on them in a real scenario. We also want to continuously improve our operations.
Weißt du, wie man deinen Sound lauter schaltet und die andere lauter schaltet? Die Tonanlage? Ist das hier? Okay.
Yeah. Give you a small example. A common operational task is to apply security patches in your server. If you do this manually, it's a time-consuming task that's complex, and automating it allows you to free up your time and save some headache. Trust me, I know that this is the case. So you can use a patch management system, for example, like AWS Systems Manager allows you to do, to define patching groups and create more isolated changes, smaller changes in your infrastructure, as well as maintenance windows, further reducing the impact in time, and then define documents that automatically let you roll out certain security patches across your server infrastructure. So this is one example of automation that you can do according to these designs. The well-architected framework also gives you best practices for operational excellence. Best practices are organized into four areas. Organizational best practices touch on the organization that you're operating in. What are its priorities? How is it structured? And how does your organization support your teams in their ability to deliver business results? One best practice there, for example, is to clearly define responsibilities within your teams and between your teams, and make them known to everyone who is involved. In preparing for operational excellence, it's important that we understand our workload and that we know of its expected behavior. We need to be able the internal state of our workload so that we're able to support observability and investigation of any issues. And I will give you an example of observability in a bit. Next, successful operations means the achievement of business outcomes at the end of the day. And we should define outcomes and make them objectives by giving them a metric. By doing that, we are in a position where we can define goals for these metrics, which would mean that these business outcomes are at risk. Once reached, we can then trigger automated responses, automated procedures to deal with those risks in a timely fashion with consistent results. So again, this topic of using automation. Finally, we want to get better over time. We want to, from our operational activities, mostly we want to learn from any operational failures. So extracting lessons learned, our activities, documenting them and sharing them across the organization helps us not to blame each other, but to get better, to learn from each other and to get better over time. And that's what it's really all about. Coming back to observability, putting observability into your application requires. On the left-hand side here, we can see the AWS native stack for observability. Starting from the bottom, we have the Amazon CloudWatch agent and the AWS X-Ray agent, which are collecting data from our infra and our applications and send them to CloudWatch. In CloudWatch, we have features to work with the data and extract insights. Even higher level features like container insights or application insights that allow us to get a more comprehensive operational overview. But of course, also want to use open source technologies for their observability stack. And we give them the flexibility and we support this with managed services for popular tools in that area. And how that can look like is something like this. On the left-hand side, for example, you can deploy in an Amazon Elastic Kubernetes Service EKS cluster with AWS distro for OpenTelemetry, using a Prometheus server to scrape metric endpoints. And these then send metrics to a service for Prometheus endpoint. This is a fully managed service by AWS. It allows you to store the data for your metrics. You can define rules. You can set up alert manager for alerting, and you have an endpoint against it. And then you can, for example, use Grafana for your operational dashboards, either a self-hosted Grafana or the Amazon managed Grafana service, which is a managed service of it. Data and power your dashboards. I have this deployed in my account. I will switch to the browser to actually show that to you. Bear with me. Might take me 1 minute.
Saalton ist nicht so laut.
Saalton is. I think it's at the maximum. Yeah, I can try to shout. Good. Okay, we can see my AWS account open. I have an EKS cluster where I have some application deployed. And so in this cluster, I also configured an add-on, AWS distro for OpenTelemetry. This is an open source distribution of OpenTelemetry. I can easily, and then it's available. Let's look at the cluster. Yeah. I thought I should do that. Let me. More. I will need to get really fancy, fit the right things on the screen. No, let's try it. So this now has an open telemetry collector. Honestly, I don't know how it's called, so let's try to figure it out. So we're looking at a resource. Well, okay, cool. We have it. We have, and we can integration kubectl. We're in Prometheus, in the Prometheus namespace. This scribe. So you the configuration and how it sends data, or where it sends data to. So we can see a lot here. This looks awfully like Prometheus scraping rules configuration, metrics from our workloads in the cluster. And then we have an exporter, Prometheus remote writer, which writes our metrics to this endpoint. And well, the endpoint of a managed Prometheus service workspace. Let's look at that now. And I think I should again, at least a little bit. Is this like, can you read this, or should I zoom back in a little bit more? A little bit more. Maybe like this. I can close this, and then I think that's fine. So we can see our Prometheus. We have a workspace that I've set up. Yes?
May I ask a question?
Yeah, sure.
Short one. The managed Prometheus, what technology is it? Is it something Amazon did? Is it something like Grafana Mimir?
Unfortunately, I don't know what we are using.
Okay.
It's also a detail that we usually don't give out publicly, because the internal implementation of a service might change. We might decide to change it for whatever reason. But the endpoints are compatible with Prometheus. So you can use it like as a drop-in replacement for your Prometheus. We can see the remote write URL endpoint here. That's the one that we have configured in our metrics collector. For our PromptQL query, we will see that later. And, we can configure rules here. Like in Prometheus, they're configured. And also set up alert manager. For example, this sends, I have an SNS topic where it just sends alerts. So I can do all of these things. Part of the diagram that I just showed you, if you remember that. And I then deployed a managed Grafana workspace. And I'm using this to, for example, define a dashboard with my operational data from my cluster. I mean, it's nothing fancy. I imported it. You get the idea. Your observability on Grafana using the Prometheus data source to get access to the data that you store in the managed service for Prometheus. That's it, really. So it's pretty easy. I've managed Kubernetes clusters with and Grafana installations in the past. I know it's well, it's not seamless, let's call it like this. If someone else takes the responsibility of managing that for you, then you have more bandwidth to differentiate yourself with. And I think that's a good thing. So to my slides.
One question.
Yeah, please.
Is telemetry, is it like the Grafana engine? So a small Prometheus server only be possible to doing remote writes? Because I saw it's scraping.
Mm-hmm.
So
yes, it telemetry works. It use endpoints to scrape metrics. We've seen that configuration. It then translates the metrics into an internal format, and then you can define exporters, like for example, the Prometheus remote writer that sends the metrics to this endpoint. What I didn't show you, what I also have in this cluster, you can just deploy a Prometheus server that does the scraping for you, and then it also can be configured to do a remote write to the managed Prometheus. So these are possible. Okay, so we've seen this stack with the Kubernetes cluster where we run our workload and we collect our metrics. We store them and manage them in our Prometheus workspace. Use Grafana for our observability. Let's move it on. Focus pillar today, reliability. Reliability of a workload is the ability from infrastructure and service failures to dynamically acquire resources based on demand and disruptions. When thinking about reliability, I think this quote by Dr. Fogels, CTO of Amazon.com, really nicely summarizes how we think about reliability. And he says, everything fails all of the time. So we need to build systems that embrace failure as a natural occurrence. This might seem a little bit drastic, but at the scale that Amazon.com, failure is indeed a constant, and being prepared for it is a good thing. So we have principles that guide you in designing, in building workloads that are reliable. Again, we have the automation here. By automating procedures, recover from failure, we can then promptly trigger those procedures to get and also consistent results. So we can, again, for example, use AWS Systems Manager to installations where we build and script our runbooks, and then we can automatically trigger them in response to certain operational or certain failure events happening. Of course, that's one part. We should also test the features. So one thing that the cloud allows us to do is to simulate certain failure events, create an hypothesis of how our system will react to these failure events, and then observe the system, how it reacts to this failure and how it recovers. If there is a difference between our hypothesis and the actual behavior, back and improve it. But that's the idea. And that's also a practice that has gained popularity recently in the last few years, known as chaos engineering. And it's a really great way to increase the resiliency of your applications. Another thing that you can do is to reduce large resources in multiple smaller ones and then route requests between them. This reduces the impact of individual failures, overall reliability. And then you can automatically add and remove capacity as the demand changes. So you always have the right level of capacity without over or under provisioning. And finally, changes to our infrastructure should be automated as well. By using, for example, infrastructure tools, we can define our infrastructure as code. We can introduce changes, manage the source code. We can changes and then automatically roll them out. Some best practices that from these design principles. Foundational best practices typically go beyond a single workload. They touch on how to deal with service quotas and restrictions, and also on networking aspects. And this is especially important for workloads that live in multiple environments, for example, hybrid workloads that are partly on-premise and partly in the cloud. When applications, we need to make some upfront design decisions that may influence its reliability. For example, by using microservices-based architectures, we can end up with smaller components that are simpler. We can manage and evolve independently of each other. I say can end up with because introducing microservices-based architectures is not trivial, so you need to put some thought into it. But done right, it really helps you. We also need to design our workloads so that they can accommodate change. And there are externally facing or external changes coming from external, the changing demand into our workload that we need to adapt to. Or internal changes, like we develop a new that we want to release, or we want to roll out security patches. And then coming back to this quote, we need to have a strategy in place to deal with failure. Failure can occur, and at a certain occur. Prepared. That means that we need to understand the business requirements for our workload, and from that we need to derive requirements for its resiliency. And we typically do that when we create a disaster recovery strategy, where we start by answering what should our recovery point objective be. This between the time of a disaster event happening and the latest available restorable data. So it's the expected maximum data loss that we can incur. And the recovery is the distance between the disaster event happening and the workload being again fully restored and delivering. Once we have these objectives in place, this is how we can architect our workload to meet these requirements. And the AWS Resilience Hub helps you doing that. It allows you to check your workload, to identify potential gaps in your recovery objective that the workload can deliver, and then it allows you to implement actionable improvements that help you converge towards your objectives. And my colleague Tom, it's your time. He has kind of a demo of Resilience Hub. Really looking forward to that. We need to switch over, and this is.
As my name is Tom Reichenbach. I'm AWS Solution Architect based here in Vienna. So you see, I didn't see the slides from Jochen before because I have a quote from Werner. Maybe I should have chosen somebody else. But just to summarize it, so just going won't make you resilient, right? You have to plan, you have to architecture. And failures happen. You can, they will happen. Maybe, you know, as it happens to a German company last month, maybe some construction work will cut up your fiber optics, and passengers cannot board in Frankfurt. It happens, right? So plan, as Jochen said, you have to plan what will you do and think about the costs, right? So I won't bother with numbers. The key point is the downtime costs. It costs you money. It costs you reputation. If you are, when you also have some SLAs, it will cost you much. Being resilient will also cost you, but hopefully less than when you have the downtime. The RTO, RPO, I already explained. This is how we quantify, how we define it. It's something that you define, and you your tiers. You have your tier. Continue. Tier 1, 2, 3, so you can define what your recovery points and recovery time objectives are. Resilience Hub is a central place, it's a hub where you can define, validate, and track your of your application. So it's application-based. And let's just jump in the architecture we're going to look. So there's a 3-tier application. There's a load balancer there. Web application, you have some auto-scaling group and RDS database. And there's an edge gateway for communication from the private subnet, and you have like storage for the static data. So it's a pretty basic application, but we want to check, we want to see how we can make it resilient, or maybe it's already resilient. So there's the hub, so you can add your applications there. So if you go there and we see the steps, actually, it shows the workflow. So you publish your application, you can assess the resiliency, and you can set up some recommendations and then run experiments. So if you want to go there, let's say we want to add an application, so we test it. So hopefully you're using the first operational excellence pillar, as Jochen said, and you do some infrastructure as code. So you have either Terraform or CloudFormation stack. You can also use existing application or resource groups. But basically, it will detect your infrastructure as a cloud, let's say CloudFormation stack, for you don't use AWS, just Terraform, where you can define your infrastructure as a code and just then install it automatically. So it will detect the applications that are in your workload. So if I select this workload and I go there, I want to daily schedule. So it will automatically detect the resources that are in my workload. The resources, I showed you this 3-tier application that we saw before.
Scale up the browser a bit so it's easier to read.
I can try. Good.
Maybe.
I don't know. I can try more. But yeah, it gets. Is this okay? This one? Anyway, you see the applications there. So the auto-scaling group, you see the S3 bucket, you see database, gateways, and so on. So I don't want to import this. So I already imported this before. Let's have a look at my web application. I already did the assessment. So it takes maybe 1 minute and so on. I don't want to wait for it. So let's say the first assessment. So what Resilience Hub does is you define your RPOs, RTOs on 4 levels. So the first one is application. What happens if your application fails? The second is infrastructure. What happens is if your infrastructure, this means hardware, it's a virtual machine. What happens if your virtual machine fails? What happens if the availability zone fails? And here we didn't use the region. What happens if the region fails? I don't know if all of you know the AWS infrastructure, but basically the availability zone is combination of 3 or more data centers, and then the region is combination of 3 or more availability zones. So this is how it's defined there. So we defined 1 hour for RTO for our application. It says unrecoverable. infrastructure looks good, availability zone is also unrecoverable. We can see why is this unrecoverable? Because we don't have any recovery option or backup for our database, and also we don't have any versioning on our static assets. So the resilience recommendation, and we can see some options. So the hub always gives you 3 options. One is you want to optimize for costs, one is you want to optimize for minimal changes, and one is to optimize for best RTO, RPO. So the one change would be enable instant backup. The 5 changes are the best RTO, change to Aurora, add to read replicas, and all the rest that says here. It's the cost actually that you're going to pay, estimated RPO, RTO after this, and you can compare it, what will be my new RTO. This is what's for database. For networking, it says yes, basically all 3 of them. There's only one option. You want to have highly available net gateway configuration, and for the storage, you want to do some versioning. So you can go back to the previous version. Sorry. If I want to implement this, I implement this. I have my infrastructure as a code. I do the new deployment, and of course, I can do the new assessment. So let's assume we did this. I already did this, and let's see. Now it says the policy is met. I achieved my targeted resilience, at least the RTOs, RPOs defined, right? I can look, are there any recommendations? Actually, for compute, nothing. For database, still option to optimize for availability zone that I didn't do. I can do it if I want. I can see what it would bring me. So it would bring me from 2 minutes to 0. And it will recommend me still some of the recommendation, even if I achieved everything. So now you can say, okay, I see some numbers, Tom, and it's very good, but how can I prove this? And I would say, glad that you asked, because as you said, you should test it. No, it's not like you're not resilient because you think you are. You're resilient when you test this. Switch the mirroring again. Because it's not what I wanted to show you. So what we can do, we can test this. So what are these resilience recommendations, right? And the resilience recommendation is something that you do. And then there are also the operational recommendations. So the operational recommendations are the recommendations that are also something that Johan said in the first pillar, operational excellence. So what are these actually, right? So it's activate when something happened, right? So if something happened, I can activate some of the alarms. When database load is high, there is a free and so on. Then defining standard operating procedure. How do I actually restore RDS, the backup? So I want to test this, and I want to see my actual RTO and RPOs. So this operating procedure will test this for me. It's doing these game days, as Johan said, so do some tests. And I can also some fault injection experiments. So this is the chaos engineering, what Johan was also talking about. So test what happens if will the application recover, in what time if the RDS instance boot, or what will happen when the availability zone fails. So you have all of this here, and if you want to implement this, you choose one, so you them, and you you get a nice template as infrastructure as a code. So you have to click this, you get this infrastructure as a code template, and on your workload. And then you have these alarms. So as you assume, I already did this for some of them. So let's have a look how it looks. The alarms, for example, I had 2 alarms defined. What happens when the autoscale group CPU is 100%, and what happens when the synthetic canary is something that tests your application if it drops below. I did 2 fault injection experiments, RDS reboot, and one is the inject CPU load in SSG. So when you click on this, you got transferred to the fault injection experiment, and you just like start the experiment. And this will start this experiment. It will in this case like make a failover to the database, and then either you recover automatically or you need to start your standard operating procedure. So your standard operating procedure, for example, would be, I don't know, if you don't have automatic auto scaling, you would need to scale and start this yourself. And of course, at the end, you will get a result. What you can do, Resilience Hub, you can track this. I mean, you get a resilience score that is a combination of things that you did. So I did like 3 things, 3 basically improvements. If you want to get to the score of 100, you should implement. And what Hub wants you to is at least to test once per month this standard operating procedure or the fault injection experiment. This is what comes directly from the architected framework. These are the recommendations that we actually recommend for you to be resilient. And if you go we can have a look what we did. So we started with this architecture. We added another gateway to be highly available. You mean versioning. We did automated backup, so we can restore in 5 minutes less. And Johan didn't show you this much in detail, but every of the pillars of the well-architected has some points. So you can go to this point, and when we do this review, we actually ask you the question. We ask you the question, scale over to healthy resources. So there's a link, there's the description there. And you can think about it and ask and say yes, or the modification that we did. So we added another gateway when the availability zone becomes unavailable. We back up the data. It's how you can look at your architecture, but answering these questions, and then at the end, I am well architected, or I'm not well architected, or these are the improvements that I can make. So it's the Resilience Hub can help you with, at least to automate this, and it's the continuous validation and tracking of your resilience. If you integrate this into your CI/CD pipeline, you will prevent some misconfiguration, you prevent some failure in the software propagating to your next stage, or at worst case, to the production. So you can reduce, of course, outages. And that would be it.
Thank you, Tom. I think great service that really helps you to up your game and continuously evaluate and improve the resilience of your workloads. So really something powerful to adopt. We now move it on to the well-architected framework today, which is sustainability. And in this pillar, we give you guidance on how AWS you reduce your overall footprint and some best practices on how you can improve the sustainability of your workloads. I'm a big fan of quotes, and I particularly like this one of Peter DeSantis, SVP of AWS He said, the greenest energy is the energy that you don't use. And I think it really nicely summarizes our thinking about sustainable workloads in the cloud. Some context around this. At AWS, we have a shared responsibility model, sustainability. This means that AWS takes the responsibility for the sustainability of the cloud, work hard to reduce the overall footprint of our global infrastructure. This starts with how we build our data centers, how we design our servers, and how we reduce waste throughout the system. But all services that are built on top of this infrastructure, for example, our managed services, they are optimized for sustainability. And then on the other, customer is responsible for building and operating sustainable workloads in the cloud. This means that you need to make decisions on how you store your data, which data you store, how you build your software, your systems. And again, we have design principles that guide you on how you can do. It begins with information. You need to collect data that shows your current impact and available to you. From there, you can then define goals on how you want to improve the sustainability of your workloads. And this allows you to define a roadmap that gets you there. What you can do, for example, is to optimize the resources by reducing or eliminating idle resources. You're not consuming the power that's needed to power them. You're more effective and you're more sustainable. What you can also do, and I'm really excited about this area, is to monitor for new technologies that help you be more efficient. Software, for example. I recently started adopting the Rust programming language, sorry, it's one language, for personal projects. I absolutely love it. I love that you can write really, really efficient code and that you're still productive. So this is really fascinating. It has some learning curve associated with it, but I think the ecosystem sure by now that you can really get over that quite quickly. So I really recommend that you look at that. On the hardware, we at AWS have exciting things to share with you. So we have invested heavily in our own silicon. We have released Gravity that's available in many instance families by now. And this chipset is based on ARM, on the ARM architecture. It allows you to be much more efficient with consume. So with the same performance, you consume much less power. Overall, this means that the workloads, if you run them on, are more sustainable. And in my personal project, I just use Graviton instances. More efficient, they're more sustainable, and usually your software works already really well on ARM-based architectures. Another thing is using managed services. By the scale that we as AWS operate at, we are in a position to utilize the underlying resources for those services much better than any one customer would. And that overall leads to a higher utilization, more efficiency, and more sustainability. And finally, think about your users, your customers. Think about the impact running your product, your software on their devices generates. Try to avoid the need for them to upgrade to the latest device models for them to use your products. Try to avoid unnecessary computations on those devices so that they have less power. So there are a lot of things that you can reduce your downstream impact for your users as well. I will stop here. I will just stop here because I want to use the momentum that we've built and hopefully the end I created with you to draw you in to learn more about Well-Architected yourself. So I invite you, go to amazon.com/well-architected. We have lots of resources there. I particularly want to call out the white papers that we have for the framework and all of the particular pillars. Dive into those, read a paper on the pillars that resonate most with you, and immerse yourself with the content. And in the final part, I want to give you some getting started guidance on how you can go back to your teams and start adopting it yourself. And I think the way to use Well-Architected is as a journey. So one thing we already heard, you can use Well-Architected to learn about best practices in the cloud, but you can also use questions to measure your existing workload against those best practices. And then this gives you improvement idea. You can evolve your workload and get better over time. And performing this process of answering the questions and formulating improvement plans is what we call doing an well-architected review. And we make this process of doing well-architected reviews easier for you via the AWS Well-Architected visit in your AWS account via the console. It allows you to define workloads and then different questions of the well-architected framework. It links to the accompanied best practices. It highlights the principles, so it makes it really easy for you to answer these questions. And at the end, you will get the report, identified improvements for your workload, classified in high, medium, and low risk items. And then you can go ahead to implement those improvements. Finally, some recommendations that we've seen help you increase the chances of being successful with Well-Architected. Adopting Well-Architected, it takes resources. It takes time of your teams for learning about Well-Architected, for days, and also for implementing the improvements. You will struggle to get allocations if you're not communicating the benefits of adopting Well-Architected to your stakeholders. So being clear, getting their buy-in is a big requirement to be successful in doing that. Typically, there is not a single person who can authoritatively answer all of the questions for the Well-Architected. You need to get the right group of people into the room. Well, not into the room physically because we have the tool, but they need to collaborate on a review. And then they should also collaborate on the improvement. Should collaborate on prioritizing these improvement items and then getting them done. Before you start with the review, it's also good to gather all of the relevant information on a workload. The requirements, design documents, architecture diagrams, all of the things you will need to effectively answer the questions in the review. Prepare yourself by reading about the Well-Architected framework, understand the pillars, understand the design principles as they relate to your area. And then I think you're really set up for success with Well-Architected. But I have prepared a quick survey for you. I would really, really appreciate it if you could take the 1 or 2 minutes to fill it out. We are a feedback and data-driven company. So we would really highly appreciate your feedback. It allows us to improve over time. And since we're also a well-architected organization, we want to improve over time. So, and that's a really big help. Thanks. And one But if you go out today and tomorrow you come into the office and you are all excited and you want to get started with well-architected, don't be discouraged by initial results. We can all improve. One of us can. Don't expect perfection from the first get-go. It's about the journey. It's about improving over time. So don't be discouraged. Take it as ideas of how you can improve over time, can tackle, and use it as a long-term strategy to get better with every step. And I wish you all the best. And now we can do QA. Thank you. Should we just throw it into the...
Does anybody have questions?
By the way, colleagues with me, we already seen Tom. Some of them are hiding in the background. Please chip in if there are questions you can answer really well, then by all means contribute.
Is it working already, or is just?
Yes, you can talk anytime.
Hello. I don't get if it makes any difference. So Tom, I have a question to you. Is it necessary to make a dedicated environment, like a copy of a testing environment for the resiliency simulator? Or you can just run it on the actual one and it will not affect the production system.
I hope you hear me. We don't switch.
Yeah, it's okay.
It's okay. No, so actually you can run it in your production environment. So it just gets the data. It doesn't do anything with. So you don't have to copy anything. Of course, if you want to do the chaos injection simulation, or if you want to do standard operating procedures,
yeah, CPU load, for example.
That depends, right? If you want to do it in the production, you want to test your production, or you want to do it somewhere else. But for getting the score, for getting this recommendation, you can do it anywhere else because it's just reading the data. So
But I have seen some scenarios or whatever. For example, if I would like to inject something or CPU load simulation, yes, should I take the test environment or it doesn't matter also?
It depends what you want to test. If you want to test your test environment, you want to test your procedure in your standard operating
basically,
environment.
I have two like mirrored environments. One's the production, second is the test. So I'm
you
just...
can do, of course, test in your test environment.
Because
you can do more often at one point. Yes, if they're the same.
Because question is if it really makes any changes to the real subject.
So actually make changes into your infrastructure. They try if you simulate the availability zone, so it would happen in your. If you want to run it more often, you can do it in your test environment, so on. The hub, getting the score. So there are three components. One is just the hub, your score, and the recommendation, and the alarms. Let's say they don't do anything; they just measure the data. Injection test, fault injection test, and the standard operating procedure. Of course, change your environment. So you have to take care and make sure where you want.
Yeah, and the second question, is there any tools for cost optimization pillar, or we should just apply the lenses well-architected tool?
The cost optimization is the next one. So, I'll leave it to you.
Yeah, we have the tool Trusted Advisor, which does run some cost optimization checks, like for example, right in your instances. So there are tools that you can use. There is also a lot in the cost optimization pillar is about cost awareness and visibility. So we have, for example, the cost and usage reports that you can use to dashboards that really drill very deeply and finely granularly break down your costs. So you can see their cost impact.
In Trusted Advisor or?
No, that basically in cost and use.
Oh, yeah, that's of course.
So you can use this data to and we have a workshop that guides you through using the data usage reports to build these dashboards and get really deep insights into breakdown across workloads and so on.
Yeah, because the topic of the billing is the most complicated for us. We are like a team of technicians and we are joking from it. And how can I find this workshop?
I would need to Google it.
I'll send you the
Do you
Okay.
have contact?
Yes.
Yep.
I will
So-
contact you then later.
Yeah.
Yeah, thank you.
Thank you. I saw that there's ability to import Terraform state into the Resilience Hub. Is there a possibility to use it from an external state provider? Terraform Cloud, Terraform Enterprise.
So currently the only way is to use the Terraform state one. The enterprise is still not. It's on the roadmap, but I don't know at what point it will be supported.
So it's still just as free.
Yeah.
All right. Thank you. Anybody else? No? Okay. I'll keep this cube then.
That's the last you win the queue.
So
Yeah.
that means next time you need to do the whole news section.
Oh God. Please no. Somebody take it, please.
I think the pizza is coming at 7 o'clock. So it's guys, right? 7? Okay. Yes.
Any more questions? Yeah.
You talked before about Rust. Are you using Rust? I know it's an inside question, and then maybe. But do you use Rust inside for Amazon? For some things.
We do have. We had a post. I think it was last year, where we announced that we established a Rust team. Also maintainers from projects like Tokyo. So we support with this the ecosystem. I think we ever announced how we use Rust internally, but we work closely with the ecosystem and we support the language. Cool. We also, I think it was last reInvent already, we released the developer preview of the AWS SDK for Rust. So you can interact with APIs from your Rust applications. I already did it, simple stuff, free and so on, but really nice.
Yeah, and maybe then I can ask, so you have experience with using Rust inside containers?
Yes. So I personally built a project of a containerized application built in, and it runs on an ECS cluster with instances with Graviton instances.
And there is now, so it just works, or is there some things that you might run against?
Well, to be really honest with you, I'm staggered because I'm not the best programmer in the world.
Okay.
But this thing now runs, I think, since 3 months. It has very stable consumption. It just chugs along, so it's really fantastic. And actually, what I'm really proud of is I'm using Spot instances to run it. So an ECS cluster with Spot compute instances, and it's just fine. And well, it's my personal
Very
project.
cool.
I'm cost aware. So
Yeah, it's a personal project.
It works. And sustainability aware as well, yeah.